Assalamu alaikum students. In today's lecture, we will learn about quantum numbers and the shapes of the orbits. It includes the four types of quantum numbers, that is principal quantum number represented by n, azimuthal quantum number represented by L, magnetic quantum number represented by m, spin quantum number represented by s, and shapes of the orbitals, that is s, p, d, and f. Two of the defects in the Bohr's atomic model, that is the 3D movement of electrons around the nucleus of an atom, and the polyelectronic systems were not explained by Bohr. So they were further explained by Erwin Rutherford Schrödinger. In 1926, he gave the idea that of the wave motion of electrons. Before this, it was treated as a particle, for which he was awarded Nobel Prize in Physics in 1933. Schrödinger formulated an equation which is termed as Schrödinger's wave equation, in which electrons are treated as moving with wave-like motions in 3D space around the nucleus. The solution of the Schrödinger wave equation give a set of the numerical values which are termed as quantum numbers. Quantum numbers are defined as the numbers which express the size, shape, and direction of the orbitals from the nucleus, that is the orientation of the orbitals in space around this nucleus, and the spins of the electrons. These quantum numbers actually they tell about the address of an electron, that where it is located within the atom. Now, there are four quantum numbers by name. Number one, principal quantum number, which is represented by n, which describes the size of an orbital or the energy level, that is basically shell of an atom. Second one is angular quantum number, that is represented by L. It is telling you about the sublevels or the subshells, and it gives you the shape of the subshells, that is S, P, D, or F. Third one is magnetic quantum number represented by small m. It gives you how many orbitals are there in an orbit. They gives you the orientation in space of these orbitals. The last one is spin quantum number represented by S. It tells you about the spin or direction of an electron around its own axis, whether it is moving clockwise or it is moving anti-clockwise. Here it is given. Principal quantum number tells you about the shell. Angular quantum number tells you about subshells. Magnetic quantum number gives you a study of orbitals, orientation of these orbitals in space, and then the spin quantum numbers tells you about the spin of an electron in an orbital. Now the next one is, the first one is explained, principal quantum number, that is represented by small n. It actually tells you about the size and energy of an orbit or a shell. N is the number of orbits in which electron can reside around this nucleus. You can see in this diagram, three of the n are represented here. That is, n is equal to 1. It is representing first shell, that is represented by K. The n is equal to 2, representing you the second shell, that is telling you about L. Then third one, that is n is equal to 3, it represents you the shell, that is called M. Further, it can be termed as n and so on. Right? Now, greater the value of n, larger or the bigger one will be the orbit with high energy, and the distance from the nucleus will also be increased. As you have done before, that nearest to the nucleus there lies the smallest distance of the orbit. Then as we move above, the distance of the orbits increases from the central nucleus. Right? Now, here the formula is given which tells you that how many electrons can be accommodated in any of the shell. Here n is equal to 1, which tells you that it can accommodate 2 electrons in it, given by this formula 2n square. When we are going to place the value of n in this formula, it becomes 2 multiplied by 1 raised to the power 2. The answer is 2. So 2 electrons can be accommodated in the first shell. Similarly, when n is 2, it means it is shell that is called L. The number of electrons which can be accommodated in it, they are given by the formula, that is 2n square. Once again, place the value of n in it, that is 2 square. Then it will give you the total number of 8 electrons which is present in the second shell. Similarly, in the third shell, when we apply the formula 2 into 3 raised to the power 2, the total number of electron comes out 18. In n is equal to 4, there is 2 multiplied by 4 raised to the power 2. That will give you the total number of electron which can be accommodated, that is 32. Now, this value of n also tells you about the periods in the periodic table. Do you remember? There are 7 periods in the periodic table, starting from n is equal to 1 up to n is equal to 7. Right? Now the second one is azimuthal quantum number. It is also called angular momentum number. It tells the shape of the subshells. There are basically 4 subshells which are named according to the spectral lines produced in the spectra under the high resolution of the spectroscopic techniques or the spectroscopic equipments. Here we have the 4 types, which we say S represents the sharp lines in the spectra. The shape of the orbital will be spherical as it is mentioned here. Then P represents the principal lines in the spectrum. The shape of the p orbitals are dumbbell shapes. Then diffused lines for d orbitals. They are clover leaf-like shapes. And fundamental is for the f orbitals. They are too much complex ones. Right? Now you can see the value of L is different for each of the sublevel or the subshell. For S, it is 0. For P, it is 1. For D, it is 2. And for F, it is 3. Right? Now, the value of L can be 0 up to n minus 1. Now, how this n minus 1 is utilized? You can see when n is equal to 1, the value of L will be, now find it out, L is equal to n minus 1, place the value of n in it, it will be 1 minus 1 equal to 0. It means in the first shell, there is present only one subshell, that is S, which is having spherical shape. Clear? Now here on this slide, there is given how the number of electrons in each subshell can be calculated. You should remember the value of L for each of the subshell. For S, the value of L is 0. The value of L is 0, while for P, it is 1. For D, it is 2. And for F, it is 3. You have to remember it well, right? Now here, this is the formula, that is 2 multiplied by 2L plus 1, which can be applied to find out the value of the number of electrons which can be placed in this subshell, right? So in this subshell S, the value of L is 0. So by placing this value of L in this formula at this place, 2 multiplied by L will give you the value 0, as 2 multiplied by 0 will be 0. So plus 1, it will be value 1. 1 multiplied by 2 will give you number of electron, that is 2. Right? So we will say there is only one orbital of S subshell and there can only be accommodated 2 electrons. While the value of L for P is 2, P is 1. By placing this value in this formula, what will you get? The total number comes out at 6 electrons. Right? Now here it means it has 3 orbitals multiplied by 2 electrons in each orbital, so the total comes out as 6 electrons. For D, place the value of L, that is 2. So 2 multiplied by 2 will be 4 plus 1, 5. It tells you there are 5 orbitals multiplied by 2 electrons in each orbital. The total number is given as 10 electrons. For F, the value of L is 3. By placing it here, 3 multiplied by 2 will be 6. 6 plus 1, 7. There are 7 orbitals in this subshell, that is F, and each orbital will hold 2 electrons, so the total count is 14 electrons. Right? Here once again there is mentioned the energy level, that is number of shell. Which one shell? In the first shell you will say the only orbital or the subshell present is S. The value of S, the value of L for this S is 0. The number of orbitals which can be present here, that is only 1 as given above, and it can hold only 2 electrons. By applying the formula 2n square, the total number comes out as 2. Means in the first shell you can have only 2 electrons placed in it. For the first shell there can be placed only 2 electrons. Now here comes the second energy level. In second energy level, you will find two values of L, 0 for S and 1 for P. S is having just 1 orbital while the P is having 3 orbitals in it. Right? S will have 2 electrons, but P will hold S. Each orbital will hold 2 electrons, so 2 multiplied 3 will be 6. So the total number of electrons by adding these two values will give you total number, that is 8. Right? Now, here it is given the values to remember in each of the subshell in the periodic table. If we say this is the value of N for first shell, the value of subshell is mentioned, that is L or the azimuthal quantum number, and which one subshell will be present in it by name as P, D or F, it is also given. In the first shell, there the value of L is only 0, means in the first shell there is only present one orbital or the one subshell, that is S. While in second, the value of L, there are two values. Remember it, 0 is the value for S and 1 is the value for P. So second shell will hold two subshells in it, S and P. While in third you will find there will be three values in it, that is 0 as well as 1 as well as 2, means there is present S, there is also present P as well as D. For the fourth one, there are present three values of L, means there is present S orbital, there is present P, D and F, as the value of L for F is 3. All the others hold the same values, as you know very well that the filling is just getting disorder as it is given in the periodic table. The number is decreasing in 6, the seventh one, as you know very well that the elements are still under the process of discoveries. So only up till now we have discovered up to the 7s, that are the 7p orbitals. Not more than this are still discovered. Right? Now the next quantum number is magnetic quantum number, which explains the effect of an orbital in the magnetic field, the orientation of an orbital. We say if the substance is placed in the magnetic field influence, so what happens to it? These subshells, they further split up under the three Cartesian coordinates, that is x, y and z, which gives you about the orientation of these orbitals in space. Right? Now orbitals, they split up into degenerate orbitals. Degenerate means the orbitals which has same energy. This term is important with respect to MCQs in a magnetic field, right? Each degenerate orbital can hold only up to 2 electrons, as I told you in the previous slide. Here, the value of M and L, they are correlated. What the value of L is, same is the value of M, right? Although it has resolved further, the values of L can be 0, it can be minus, it can be plus. Okay, now here we have the value of M, or the magnetic quantum number, for the sublevel S. As you know, the value of L for this subshell is 0, so the value of M will also be 0. Means the probability to find this orbital is only lying at the central axis. Everywhere around this, it is spherical one. The what you say, the density is equal, right? Everywhere, as it is a spherical one shaped orbital, right? Now the next one is P, for which the value of L is 1. There are three possibilities that under magnetic field it's split up with three lines. One which goes towards 0, one which goes upwards, and the other one which goes downwards, right, along the axis. So what will you say? There can be values 0, -1 and +1, right? Here we have the three values of E, means there is present, when we say 0, it is Px, -1 Pz and +1 Py, right? So three further orbitals are being there, three degenerate orbitals are present for the subshell P, right? Now next one, that is D. For D, you are familiar with, as we have done earlier, the value of L is 2, the value of M is also 2, but you will find there 5 values, one with 0, the other one with -1, the next one is with +1, and you can also have -+2, right? So it indicates you there are present 5 orbitals which are degenerate orbitals in the D subshell, while F includes 7 orbitals, as the value of L for this orbital is 3. So M will be 3 minus +3 minus +2 minus +1 as well as 0. If you count them, they comes out as 7. These resolutions are according to the electronic clouds which are found on these three Cartesian coordinate axes, that is x, y and z, right? Now here it is given the relationship between L and M. L means azimuthal quantum number and M means the magnetic quantum number. Here you can see when the value of L is 0, I think you remember it now that it is the 0 value for S subshell. The number of orbital for this is only 1. So the total number of electron which it can have, that is 2. There is just one value of M, that is 0. It means it is of spherical shape. Now here, when the value of L is 1, means there is present P subshell. It is further resolved into 3 orbitals. Each orbital can hold 2 electrons. So the total is 6. These p orbitals have 3 values, 0, +1 and -1. You can say px, py and pz, right? Similarly, when the value is 2 of L, it means it is subshell B. The number of orbitals which it has, that is 5. This is the 5 degenerate orbital which are present in D. Each orbital can hold 2 electrons, or the total number of electrons which can be accommodated in D, that is 10. And the 5 values of M are possible for this. There are 5 splittings: 0, +1, -1, +2, -2. Similarly, when the value of L is 3, means F subshell, there are 7 orbitals, and these 7 orbitals each can hold 2 electrons. So total is 14 electrons. The 7 values are possible for this, means there are 7 electron densities which are present on the Cartesian coordinates separately, right, in the different shapes. Here we have 0, +1, -1, +2, -2 and +3, -3. Now the last one is spin quantum number. Spin quantum number is represented by S. It gives you about the direction of the spin of an electron. As you know that electron is not moving around the nucleus in the orbitals or the orbits, but it is also rotating around its own axis. So its rotation can be of two types. It is a self rotation. It can be either 50% clockwise, or it can be either anti-clockwise 50% as well. So it is denoted as, when there is -half, means it is clockwise movement around its own axis, and when it is +half, means it is anti-clockwise moving around its own axis. Here it is given, if the 2 electrons have to stay in one orbital, as I told you that there are present only 2 electrons in each of the orbitals, so they will stay there. If they have 3 quantum numbers same, but the spin quantum number for them will be different, then they can stay here in one orbital, right? You remember, you place the electronic configuration like this in a block. You represent it like upward arrow as well as a downward arrow. This represents you a pair of electrons present in one orbital, right? Here it is given the anti-clockwise movement. This is the anti-clockwise movement, and this is the clockwise movement, which is represented by -half, right? Now here we have, now just apply all of these quantum numbers on one of the electron present in s orbital. Here it is given. Consider there are present 2 electrons in one s orbital. In one s orbital, that is the first shell. N for this will be 1, right? This 1, in this 1s, 1 represents you principal quantum number, that is 1. Right, for these 2 electrons, the start of the address, you can say, as you say that in Pakistan is the main, suppose it as an atom. In this Pakistan there are cities that will give you about the subshells, and then there will comes that of the in that in any of the city, you say in Karachi, again there are areas you can locate over there. They are giving you where the electrons are residing, and here there will be some what you say house where it is living. So start from shell, then there will be subshell, then there will be orbital, and then according to their spin, the two of them, if there are 2 electrons, they will stay in same home, but each of one will be with the opposite spin, right? Here we have 2 electrons in one s orbital. So how to locate their address for each electron? Here we have, for example, first electron in this you will find there the value of n for each electron is 1. As I told you, in 1s, 1 represents your number of shell. I think you are familiar now that the value of L for S is what? For S it is 0. If value of L for S is 0, its M value is also 0. And here we have one of the spin, means this electron is moving anti-clockwise as it is given with the plus half. Now, what about the second electron in the same orbital? For the same electron, you will write here, there N is same, that is 1, L is also same, M is also same, but the difference is here that this one is moving clockwise direction around its own axis. Okay, now you can see three quantum numbers are similar for a pair of electrons residing in one orbital, but the fourth quantum number will be different. Right? Now, if they have to stay alone, for example, if I have only one electron in this 1s orbital, so then I can, for example, for hydrogen, so then I can say it can have any of the arrangement, that it can move clockwise or anti-clockwise. All the other parameters will be similar, that all will be n is equal to 1, l is equal to 0, m is equal to 0 for them all, for that electron, but its m will be, it is possible whether it moves clockwise or anti-clockwise if it is residing just alone in an orbital, right? But if you have to place a pair, then it should have three same quantum numbers, but the fourth one will be different. Now here the difference between orbit and orbitals are given. Orbit is the circular path of an electron around the nucleus in which electron has to move. These orbits are denoted as n is equal to 1, 2, 3, 4, 5, 6 values, right? And integrals values they are, whole number values, while they are designated as the K, L, M, N forms, right? Now here it is given, it is quite easy. I think you are familiar with it. What about the orbital? Orbital is considered as the area or the region around the nucleus where probability of finding an electron is maximum. It is termed as an orbital. It is called orbital, right? The area where probability of finding an electron is maximum around the nucleus. This is called orbital. And the probability where it is being found maximum, this is called electronic cloud, or you can say this is a region of the electronic cloud which is present around the nucleus. It is called orbital, right? Now, as I told you, in orbit there can be values n is equal to 1, n is equal to 2, 3, 4, 5. Similarly, here you will find in the first shell there is present s, in the second there is also present s, in the third shell there is also present the shell that is s subshell, right? You can see this is the first orbital present in, as name is indicating, 1s. 1 indicates the shell number and s indicates the subshell number, right? Similarly, the second one, the cloud is a little bit bigger. In the second shell, again S is present and it is of the same shape, that is of spherical shape, as you can see. But the sphere is going to get enlarged. Similarly, in the third one, it is the third shell and it is having s orbital a little bit larger than that of being present in second and the first one orbits. The cloud becomes larger, right? So we say the region to find the electron become increased. Electronic cloud has become expanded, right? So this is the difference between orbit and orbital. Orbit is a circular path where electron has to move, while orbital is the region around the nucleus where probability of finding electron is maximum. the shape of s orbital is spherical, and as the s orbital is the part of each orbit, so name can be 1s, 2s, 3s, 4s, 5s, and so on. The number 1, 2, 3 indicates to which shell or the orbit it belongs, right? As you can see, the electronic cloud is expanding as the number of shell is increasing, as the shell is getting large, right? Now here you can see the shape of s orbital is given under the three-dimensional space. Here it is a spherical one, where probability of finding electron everywhere on all the three axes, that is, and centrally it is what you say, same everywhere. It is spherically symmetrical. While p orbitals, they have the shape which is called dumbbell shapes. Here L is represented by lambda, so don't be confused, right? The value of L for S is 0, M is 0, but the value for the p orbital is L is equal to 1, M is equal to 1, M is equal to 0, -1, and +1. Here they are given the three separate one orbitals, this one, this one, this one, and under the three Cartesian coordinates. And here the overall, when all the three, they are fixed together in the three-dimensional space, this shape arises, right? It is a dumbbell shape. Now here the d orbitals, as we are going further, the shapes becoming complicated. Here you can see the two of the axes are occupied. If this is a double dumbbell which is present over there, it's a clover leaf like shape which is placed here. For d orbitals, the shape, the L value of L is 2, while for value of M there are 5 values which are possible. So there are 5 orbitals you can see named as dx2, dy2, dx2, y2, dzx, dyz, and dxy. These 5 orbitals are there. Similarly, in F, there are 7, as the value of L for them is 3, and for M it is 7. So 7 values M represents that there are 7 arrangements or 7 electronic clouds which are present on different axes. Here the 7 ones are given, right? The shapes are quite complicated. You don't have to remember the names of these, right? You have to go up to that of the d orbitals. Now it is end of today's lecture. Okay.